Hello, my name's Todd Gooch. Today what I'm going to be doing is an acid-base reaction. I had started one in a previous video, but didn't really have the time to finish it. Okay, so here we go. We're going to do classic sodium hydroxide. Here's sodium. It's a key element. There's its key. It's the primary site for bonding in this atom. These are all secondary sites. These are secondary keys. They're not active in the bonding here. You can use a plus there if you want on the primary bonding site, the key. Then what we're going to do is we're going to put the oxygen here. It bonds in a single bond to the sodium. And then we add a hydrogen down here. This is a half bond. This is a single bond. This primary key of the sodium atom, it activates through the mechanism of bonding here, this site right here, to give it a positive or partial positive charge. At least that's the way the standard model would say it. And then it encounters a water molecule. Let's do water. Here's oxygen. These are the secondary keys of oxygen. They're secondary sites. They normally wouldn't be active in bonding, except that we have these hydrogens that are bonded to it. And just like over here with this sodium that activated this site, these have a partial positive charge here, but that's not where the bonding occurs. The bonding actually occurs right here, where there's a full negative charge. This is an exposed keyhole of hydrogen, and it's attacked by the key of the activated secondary key of the oxygen onto the hydrogen of water, and what happens is it strips it off. So again, we'll go ahead and draw this molecule again. The sodium and then the oxygen. With the hydrogen down here, and then we had the positive to partial positive charge on the secondary bonding site, secondary key of the oxygen on the sodium hydroxide molecule, which has now stripped off the hydrogen atom, making NaOH2. The positive on this molecule site specific onto this hydrogen. That's where the bonding is going to take place next time. That's where the actual charge is. They'd probably try and tell you that there's a positive right here, and this runs the molecule, but it's not. This is where it is. This does exist. There is a partial positive. They are correct, but really the actual charge in the bonding is taking place right here, and then it leaves us with the conjugate base, the hydroxide molecule. It's actually an ion, the hydroxide ion. And here it is. With a large negative right here with the exposed keyhole, which is a primary bonding site on the hydroxide ion. And it's exposed, so this is where your next bonding would take place, saying if we were to do something like add an acid or whatever. My name's Todd Gooch. Here's an example of an acid-base reaction, real simple, with a conjugate base and your conjugate acid. I advise you to get my book. It's How to Draw Molecules Without Using Molecular Orbital Theory or Hybridization. And you know, I mean, when I started out, I would have never believed that you could do it, but over my 20-some years, this is what I've come up with, and it just works way better than Lewis structures. Thank you very much for your time.